Good afternoon.
Good afternoon.
Uh, Actually, I have got one question to make. That query that in the last class regarding the pressure. One question that has been asked in the assignment 5. Uh,
In the assignment 5.
yeah. Question number 8. From the expression of pressure in terms of chemical partition function for 1 mole of an ideal gas at 300 Kelvin in terms of gas constant.
Mhm. I will discuss that today. I thought question number 8 to question number 11, 12, I will solve today. Okay, from assignment
Okay,
5.
okay, okay. That's fine. That's fine.
Because I thought that these questions are quite tricky, maybe tricky. I don't know. I did not go through, but by reading the question, it seems to me that these questions are good to solve in the class. Okay, so I will solve
Okay,
them.
okay.
Okay, so let can we can start now. It's 4-1 already. Let me see. I will bring first. Okay, is it visible now?
Yes, it is visible.
Okay. Okay, so let me start with that part, which I did not solve in the last class. I just mentioned that I told you to try it out, but okay, let me do that because that is not very much difficult. As I mentioned yesterday, in not yesterday, in the last class. So let me start with that because this part will help you to derive the form of pressure as well. After solving that, we can discuss that question from assignment number 5. So it is. The first question is entropy, derive the expression for entropy under canonical distribution or ensemble. Okay. So what was the expression? We already know the expression for entropy. That is our KB ln Q plus E average by T. So it is actually S average. You can write it as S as well. It does not matter. So this expression we need to prove. So how we can prove this expression? For that, you know what is our Q? Q is our partition function, which is canonical partition function. We know the form of canonical partition function, that e to the power minus beta Ej. This is our canonical partition function, or more explicitly, we can write it like Q, which is function of NV and T. This is function of NVT. So this is our canonical partition function. Now we can define a function, any function, let it is.
Yes, yes.
The Bluetooth was disconnected. Sorry for that. Okay. So let me define a function which is f is ln q. This is our function. So eventually f will be also function of nvt, as q is function of nvt. Now what we can do, if this is f, so how we can define df? What will be df? Let's say when a function, any function, fxy, we don't know if xy in the form of xy, it may be like x square plus y square, where f is function of two variable, then what will be df? Df can be written as, the definition, we have to write it like d del f del x constant of y dx plus del f del y constant of x dy. Okay, so here these are the partial differential, okay, partial derivatives or differential. These are when the more than one variable is there, then we have to consider the partial derivatives. If only, let's say, f is only function of x, like x square, then we can write df dx. This is correct. Okay, but when there is more than one variable, so in that case you can write total change this is as just like this. This is correct. But if there is more than one variable, as here I have mentioned, the xy equal to x square plus y square, then we have to consider this. Because in that case, when f xy, the function is x square plus y square, you can't write df dx. This is totally wrong. This expression you can't write. This expression means ordinary differential, okay, or ordinary derivatives. And here this is partial derivatives. Partial means you can understand this is only a derivative with respect to one variable x. That's why it's partial derivatives. So that's why you have to write. If you write this, this is wrong. So del, instead of d, you have to write del x constant of y. Okay. So now you can do it. Del x constant of y. What will be it? Now you can see y is constant. So that part will be 0. Only 2x will be there. Similarly, del f del y constant of x, it will be 2y. Hence, total df will be 2x into dx, 2x dx plus 2y dy. So we can directly write it from here, but the actual mathematical steps are like this. We have to write it like in this form. This is total df, and then you can do it. Okay. But if there is only one variable, in that case, there is only one derivative, that is ordinary derivative. So full derivative or ordinary derivative, and think, not partial derivative will be considered in that case, because there is only one independent variable x. Here, f is function of, you can see here, nvt, or you can write it f equals to ln q. Now you can write it like this. Q, you can visualize that q or f is a function of beta e1, e2, e3, and so on. This is also correct. because q is essentially function of these all things, because q is e to the power minus beta ej. So you can think just we have write in different form. Beta is actually the function of temperature, and this all energies are function of NVT. All energies are function of NVT, right? That's why we have write like this. So essentially, you can write that F is a function of these quantities, beta, E1, E2, E3, you don't know. J goes up to infinity. So what we can write then, what will be df? Df will be del f del beta. This is partial derivative with respect to beta. When all J's are constant, this suffix denotes the constant. Here y was the constant, here x was the constant. So del f del beta when all J's are constant into d beta plus del f E1 when beta is constant and from E2 to E infinity all are constant. Okay. dE1 plus del f dE2 again beta E1 E3 all are constant except of beta, and it goes on. So in general what we can write, we can write it, this part is correct, del f del beta Ej is constant d beta plus sum over j del f del Ej when beta is constant and all e except j is constant. I think the notation is clear. All ek, k is the another dummy variable. You can write k, lm, and anything, j, I, anything you can write. So all energies are constant except Ej, because you are taking the derivative with respect to Ej, and that j will vary from 1 to infinity. So when j equals to 1, this term will be reduced in this form. When j equals to 2, this will come out, and it goes on. So this is our general expression for the df. So we have to calculate this df. What will it be? So for that, first we have to calculate this term. So let us calculate first. If there is any doubt, you can ask me, okay? These things are quite mathematical things. You will be familiar with these stuffs. Okay. Because these partial derivatives will come again and again. This type of b k not equals to j, this when more than one variable. In thermodynamics also you can see these things. Classical thermodynamics. When there are chemical potential gives you an equation in that part also, in 1, in 2, and 3. Also these things are there. So we have to first calculate this del f del beta when the all energies are constant, Ej. So what will be it? Let us calculate. So I'll calculate it. So del beta, and this is ln q. ln and q is e to the power minus beta Ej. So what would it would be like? Just sum of r j e to the power minus beta Ej, or for being simplicity, you can write it like this q. So it will be 1 by q, and it is del q del beta, okay, when all Ej's are fixed. Now del q del beta. Mm. 47 into del. Okay, so we can write it now. So let us do it. So this form is quite known to us. What should it be? It is just minus of E average. Because what was the form of E average? It is minus 1 by q del beta nv. Okay. So instead of NV, we can write EJ. That does not matter because EJ is also form of NVT. So explicitly, you have to write it NV because beta you have already taken out. So only NV will left. So it is just average of E. So this part essentially signifies the average of E or internal energy. But what does this part means? That also we have to calculate. So for only one energy, we can calculate for, let's say it is EJ. For any energy, jth energy level. So we have to calculate this part when beta is constant and Ek except J. These all are constant. So let me derive it. J, it will be just ln q, or ln, instead of ln q, you can write it k e to the power minus beta ek. Okay, one thing here you have to understand. Why I have written here q equals to this part? This is, we have already discussed this q is e to the power minus beta ej, right? This is we have discussed, but here we can see I have written uh, k instead of j. Why this we have written? Because this k and
Dummy index.
hello,
Because they are dummy index.
yes, these are dummy index, correct. But why this dummy index is needed? Okay, some problem must be
So
arise.
only one energy level will be we take the differentiative with differentiation will be done for only one energy level.
Yes, because
We will
here
exclude all
J
the.
is indicating a fixed energy level, so that is fixed. Here, so J can't be variable here. Okay, so that's why we have to consider another notation, which is K. Yes, this is correct. Also, there is another term, another concept that is called, if you consider the cross term, if you account the cross term, then you have to consider the dummy variable. That is also important. Let's say I take an example. Uh, let's consider the y, any y. This is not related to this problem. Okay, just I am writing this. This is just summation of xi equals to 1 to 2. If I say this, okay, then if you have to calculate y square, how you can calculate? If y square, then x equals to 1 to 2 xi, then square. If you do it, this means y into y. Now, if you calculate y square, that means y into y. So you can do it like this. So now expand it. So it is x1 plus x2, and this will be. If you don't want to expand it, then how you can write it? Because both are I, x I square. You can write it. If I'm not wrong, you can stop me. So it will be this. Okay. So is this correct? Y square should be this.
No.
Hmm?
No.
X1 plus x2 whole square.
No, not whole
Plus
square.
plus x plus x1 x2 should come.
Yes.
X1.
So just if you do it, if you consider the y is just x1 plus x2. Right. Now, if you do y square, then obviously it is x1 plus x2 whole square. But if you open it out, then it will be, this part will be there, na 2x1, x2, and this part. This will be the form for y square. But if you follow this procedure, this cross term is neglected. You can't account the cross term. Why this is happening? This is the cross term because this constant x1 and x2 both, these are called cross terms. So this cross term will be missing out if you consider same variable. then it will be missing, it will be missed out. That's why to account this cross term, we have to consider the dummy variables here. Both can't be I. So we have considered one I and another j. Then you can write it sum over I equals to 1 to 2, j equals to 1 to 2, xi, xj. Now you do it. Then it will be first open the sum for j, then it will be xi x1 plus xi x2, then open the sum for I, then it will be x1 x1 plus x2 x1 plus x1 x2 plus x2 x2, right? So see, it will be x1 square plus 2x1 x2 plus x2 square. Now you can account this cross term. So when you consider both variable as I, then this cross term will be missing out. That's why in these cases, it's necessary to consider different variable so that this term can be accounted, this cross term. Okay, that is also one of the reason here we have considered this different notation j and k. So you will see this dummy index, using this dummy index is very important and very necessary to contain this cross term and as well as that derivative when both variables are there. Okay, so now we can do this variable, that not variable, the differentiation. So what was that? The differentiation. If my voice is breaking, then you can say okay, because my headphone, I don't know, it's not working today. It's again and again disconnecting. So I'm not using the headphone today. So maybe voice can be bit. Okay, so it is del f. Let me write it again. Del f del ej beta. So it will be ln sum over k e to the power minus beta ek. So we have to differentiate this part. So how we can differentiate? First, or we can think like this. Let me do it. So it will be just 1 by sum over k e to the power minus beta ek, and then it will be just del ej sum over j e to the power minus beta ek. So this part is just 1 by q, first one, and here summation will be coming out, and then it will be del of ej e to the power minus beta ej. Okay, so now what will it be? You can write it del ek, here it is ek, e to the power minus beta ek, and del ej del ek. So from the first part it is minus beta e to the power minus beta ek, and this part, do you know what is this? What does it call?
delta delta
Yes,
ik.
yeah, jk, Kronecker delta. This is called Kronecker delta. That means, what does it mean? Delta jk, it may be ij or it may be anything. So it means that when, oh, let me do it, because this is very important concept, this Kronecker delta. Yeah, this is this, right? Q. What j is jk, right? So j. I have write it wrong. K should be here, so it would be kj. Same thing. It does not matter. Kj or jk, it does not matter. So it means that when k equals to j, it will be del Ej by del Ej. So it is essentially 1. And when k not equals to j, then it will be 0. Okay, so Kronecker delta means you can see from here, only when this k will be equals to j, then only it survive. Otherwise, it will be 0. So by example, you can understand it. And let's say we are differentiating a function y is equal to, again we are taking the same function x1 square plus y1 square, or x1 plus sum over I equals to 1 to 3 x1 xi. So it is essentially x1 plus x2 plus x3. So if you differentiate del y with x1, so how to it be that del of x1 plus x2 plus x3. So it is 1 plus 0 plus 0, so it is 1. Or for more, it may be square. Then it will be, for first one, it will be 2x1, and then both other terms will be 0. 2x1 will be there only. But it can be done because there are only 3 parts. If you want to do it by using the summation, then how you can do it? So you have to write it del of x1 sum over I equals to 1 to y xi square. Okay. Or if you want to do for any x, here it is x1. If I want to say for x2, then it will be obviously for x2. Try to understand this part because these are quite mathematical applications. It will be used again, very often it will be used. So here it will be 0 plus 2x2 plus 0. So it will be 2x2. Or again you can turn it for, you can do it for a dy del y del x3. But in general, if I want to ask what will be the form for this, for xj, so then first you have to consider different variable j, because here we have used I. This part we have already discussed why we have to use this. So it will be this one. So we can write it, some summation can be taken out. So just xi square. So now you can see it. So what we can write it here, it's j. Here it is xi square. Here instead of j, you can write xi and xi xj. Same thing we are doing. So it will be sum over I to xi delta Kronecker delta ij. So now see, when only I equals to j, then it will be survived. Otherwise, it will not be survived. Just open the sum. You can sum. You can understand there is only 3 variables, so you can open the sum. So it will be x1. Then it is j. You are j means by with respect to which xj you are differentiating. For let's say we are doing, you can check for x1. That means j equals to 1. So it will be 2xi delta I 1. So just open the sum. So it will be x1 delta 1 1 plus 2x2 delta 2 1 plus 2x3 delta 3 1. Obviously only this will survive because I equals to j, and this will be 0. So it will be essentially 2x1. You can check. We have 2x1 and the result procedure are also same. Here same things we have obtained. But for make a general thing, we have to consider this delta. Here you can see we have done the same thing which we have done here, but here we have considered all I. So this is in general. So, so that's why delta 1 1 we have to consider. Here we have also done the same thing. You can see here for how this has x2 x1, because this means that 2 x1 square divided by del x1 into del x1 by del x1. So it is essentially into del 1 1 is there into 2x1 is multiplied with already delta 1 1. That's why it is 1. But here why it is 0? When you differentiating this delta x2 square by delta x1, that means you are doing in your mind like x2 into x2 by x1. So this part will be 2x2, but this is 0 because x2 and x1 are different variable. That means it is delta 2 1. So you are doing this 0. You are doing this, but using Konecker delta, it is easy to generalize the equation. So that's why this delta kj appears here. So we can write it 1 by q. So see, only when k equals to j that will survive. Other will be 0. So summation will goes away. For other, you can open the summation. Here also we have opened the summation. But see, only the first part will be survive when the I equals to j here. So we can directly you can write it from here. It will be a from here also it will be just 2xj because when I equals to j that part will survive. Other part will be 0. 2xj. So here also can write it beta e to the power minus beta ej. Okay, so what is this? So let me correct e to the power minus beta ej. So what is this?
Q.
So we can write it minus beta into pj. This is probability. Okay, this is probability. We have already discussed this part. Just e to the power minus beta ej by qj. Qj is partition function. So this part is just beta pj probability. So now we have both the part. This is daily, and this part essentially signifies the pj, beta pj, the probability. Now we can write it. Combining the result, we'll obtain. Combining the result, we'll obtain that df is what was df? Df was del f del beta when all ej's are constant into d beta plus sum over j del f del ej when beta is constant, all other ek's not equals to j are constant into dej. So this part we have already obtained. This is minus E average into d beta, and this is also minus beta pj dej. Okay, or we can write it minus beta j pj. So essentially you can write it df plus beta equals to minus beta pj dej. Okay, in both side we can add this part. In both side we are adding this part. So then it will be this. So this we can write it just f plus beta daily. So first it will be df, then beta df, then d beta. So this is just like d of xy. What will it be? Dx plus dy, like these things. So it will be just beta. This part is constant beta. We have used this equation in last class. So for deriving this, we need this procedure. So this part is clear, I think. Now, if this is the form df ej, already in last class we discussed that we know E, E is our internal energy. So from in our thermodynamics, first law of thermodynamics, what is U? This is U, and U is essentially change in U. We can say what is the first law of thermodynamics, that du equals to d cross q plus d cross w. So you can write it daily change in internal energy. It must be uh, sum of these two terms, del q plus del d cross w. But you know what is E average? E average is sum over j ej pj. So what will be del E or de? So it is sum over j ej EPJ, and these things we have already discussed. Just I am reiterating this part. So we have identified these two part as a this part as a heat D cross Q and this part as a work D cross W. Obviously for reversible process. So this part we have identified this part. So now what this part we have. So from here we can write it. See, DE average minus sum over J EJ DEJ equals to sum over J EJ DPJ. So we can substitute this here. So we'll have from here beta sum over J EJ DPJ. Okay, this is clear. So what is this? This is our heat. So this part is our heat. So it is just beta B cross Q, and you know beta is 1 by kBT, and D cross Q by T is just entropy. So it is essentially ds by kb. So this is essentially ds by kb. So you can write it. So ds will be then kb into d of f plus beta del E. This is ds by kb, so just multiply with kb, we can obtain this. Now it's easy, just integrate both sides. So you will have s or s equals to kb f plus beta daily with the integration constant that will be there, and we have considered that constant as 0 for simplicity. Last class we have argued this part. So this is, so we know f was ln q first, or we have already considered this as ln q, and beta kb will be just 1 by t. So this was the form. This is our expression for entropy. That is a standard procedure to deriving the form of entropy. Okay, so is there any doubt? You can ask me, because it is quite a long derivation. Then I will proceed to the next question.
Excuse me. At last part, I have got some doubt.
Yeah, ask in
Yeah, beta times delta Q.
beta times delta Q.
Yeah, it is delta Q by kBT. Okay, okay.
This part.
Yeah, yeah, yeah.
Yes.
So we are expressing beta delta Q. Huh?
Yes,
So
beta
that.
delta Q. And beta is 1 by kBT.
Uh-huh.
So, and we know from our thermodynamics, ds equals to d cross q by t.
Okay, okay.
Just I put it here. So d cross q by t will be ds, and kb will be remain as it is.
Now, how it is so ds comes here.
No, ds I obtained from use that our thermodynamics lesson. You know from thermodynamics, this is the definition of entropy. ds equals to d cross q by t. So d cross q by t will essentially be ds, right?
Okay, okay. Now dq has been replaced, na?
dq by
Here
t,
the
d cross q by t has been replaced with that ds.
yes, yes.
Yes, yes.
So this is the formal derivation for the entropy part. Okay. Okay, now the second question. Question number 2. Thermodynamic equation of state using from statistical thermodynamics. So in last class, we have discussed that entropy, pressure, Gibbs free energy, Helmholtz free energy, enthalpy. This expression we have derived in terms of the statistical thermodynamics. We have derived, but we have this is important to derive the thermodynamics equation of state, because we know that this is very important for a state, thermodynamic state. Okay, what was the thermodynamics equation of state? So there was two thermodynamics equation of state in classical thermodynamics. Here we will discuss only one. Other one can be derived following the same procedure. You can try that. So what is the thermodynamic equation of state? That is pi t, which is called internal pressure, equals, which is defined by del u del v t. That is essentially uh, t into del t v minus p small p pressure. So this is called thermodynamic equation of state. So this we have to derive from the statistical thermodynamics. It should be derived. So first we have to, let me start. What was the definition of pressure? In last class we have defined this. That we know that dEj equals to, it can be understood from our classical thermodynamics. What was that? PdV. So you can write it that dEj equals to PdV. So it is minus Pj dV. Okay. So from here you can understand this. So that means Pj will be dEj dV when n is constant. So this was the definition of the pressure, statistical pressure or the microscopic pressure, whatever you want to say. Okay. So now you have to derive this equation, right? So just look at this equation. What is here? This is del u del vt. So similarly, you have to derive this part. Del u del vt means this one should be, instead of u, we are using the average of the internal energy, average of energy, that is essentially the u. So instead of t, we can write it beta and number of molecules n. So this is our the left hand side. So first we have to derive this, and then we have to derive this part. Pressure already we know, so we can do it. So let us do it. So this is del E del V n beta. What is the form of our E average? That is we know, that is EJ PJ, and PJ is e to the power minus beta EJ by our partition function, right? U, when the n and beta are the constant. Okay. So this is the rule we have to use of the derivative rule. There are rule of derivative, right? We know, let's say u is function of x and y, and x is there, then we have to do it now. Derivative rule for uh, fraction, this fraction part. So what will be, this will be q into del v sum over j. It's easy. Del q del v sum over j beta ej divided by q square. So this is the formula we are using. This is a d of u and v, this formula. When it is u v, you know very well, u will be v there plus v into du. But when u by v, that formula I'm using here. So the first term is, it will be 1 by q del v sum over of j ej e to the power minus beta ej, and the second term will be 1 by q square del q del vita del q del v when n and b are the constant. Here also n and b are the beta are the constant. Sum over j ej e to the power minus beta ej. Okay. So again, two term appears. First, we have to discuss this part. It is easy. It is just del v of sum over j ej e to the power minus beta ej. So you can write it. First, taking the derivative with respect to ej with respect to v when n and beta are the constant and e to the power minus beta ej plus, again we have to consider the second part ej, then e to the power minus beta ej we have to take with respect to beta. So from first part it is, what is this? Ej by dv, this one, pressure, right? So this is pressure. So it is essentially the pressure minus pj e to the power minus beta ej, and the second part it is ej, and it can be understand this derivative. It will be minus beta. Let me do it. It can be written as e to the power minus beta ej into del ej del v n beta. It is easy. Now this part. What will be this? This will be just minus beta e to the power minus beta ej. And this is again pressure. So it is again minus pj. So the first part is pj minus pj e to the power minus beta ej, and second part minus minus will be plus beta ej pj e to the power minus beta ej. So you have obtained the first term is obtained. Now there was a 1 by q also. So if you account that 1 by q, then it will be, so 1 by q of del v, this part. So this part we have derived, this is this. So this will be sum over j minus pj e to the power minus beta ej divided by q plus beta sum over of j ej pj e to the power minus beta ej divided by q. Don't confuse this pj, small pj is the pressure. Okay. So what is this? This is small pj and this is the probability. Probability we already know. Pj probability is e to the, from the first class we have defined this. This is the probability. So it is pj. And this beta sum over j ej pj. Let term this ej pj at x as xj, and it will be again capital Pj. So this will be minus p average, because we know any average, any x average is defined as xj pj. So it similarly it will be then x average. So we can write it minus p average plus beta, it is ep, x was ep, so it is just ep average. So first term we have derived, this was the first term, this first term we have all derived. This comes out minus p average plus beta ep average. Now we have to derive the second part. Okay. So now for second part, you can see this is q square. This is just E average. So just we have to derive this del q del v. Just we have to derive this part del q del v when n and beta are the constant. So it will be essentially e to the power minus beta ej n beta are the constant. So again, similarly, we can do it. Oh, sum over j is missing. So sum over j. So we can write it like this, and del ej del v n and beta are the constant. So you can see this part, this will be just minus beta. Again, it will be to the power minus beta ej, and this part is pressure again minus pj. We are following the same procedure. So it is pj beta will be coming out e to the power minus beta ej. So okay, so now this part can be easily calculated, this part. So what was that? So total part was 1 by q square del q del v sum over j ej e to the power minus beta ej. So you can write it 1 by q and del q del v. This is we have obtained beta sum over j pj e to the power minus beta ej. This into sum over j ej e to the power minus beta ej from this part, and 1 q will be there. Okay, there was q square, so first 1 q and another q. So it is beta, and again you can see it is just sum over pj, and this is probability capital Pj, and here it is just ej e to the power minus beta ej q. So we know this is our internal energy, average of internal energy, and this is average of pressure. So it comes out like this. So this part all you can do it by yourself also. This is very easy. So it is E average into P average, and beta is there. So we have already three terms. So you can directly write the result. So we have result that del E by del V when n beta is constant, we obtained first term was this minus P beta EP average minus P plus beta EP average, and second term was second term is beta E average P average. So again minus beta E average P average. Okay, so this is okay, but you can see this is not uh, the exact form of this thermodynamics equation of state. This is the left hand side, but the right hand side is like this. Pressure we obtain, minus P is there, but this is not this part, right? So this part should be also there. Minus P already we have matched, and this part we have to derive. So we have to now calculate del P del T V. That should match with this rest of two parts. So what we have calculated, del P del T V. That should match. Then we can say that thermodynamics equation of state has been established. Okay. So del P del T V. So this can be also calculated. This is not very difficult task. So let me calculate it like this way. Del P del beta NV into del beta del T. So del T, beta is 1 by kBT. So del beta del T, we know this is del T of 1 by kBT. So 1 by kb will be coming out, and this is minus 1 by t square. So you can write it minus 1 by kb t square del p del beta nv. So this you have to calculate. So it's also easy. It can seems very difficult and very lengthy, but if you do it by your own, it will not very difficult. It is just derivatives. Del beta and p. So p average we know, because here we are using statistical mechanics, so we have to use the p average instead of p. So what is the p average? P average we have already defined. P average is Pj, capital Pj, and capital Pj is probability, just this. So take the sum out. It is del del beta of Pj e to the power minus beta Ej by Q. Okay. Again, we have to use again that form of U and B. This formula. So for that, let me do it writing this way. Del del beta. Some remains here. Some can be removed. Later we'll. Okay. So it will be again similarly, Q will be there. It will be del del beta sum over j pj e to the power minus beta ej minus del q del beta. You can check this formula. This is available in class 12 math book. Pj e to the power minus beta ej divided by q square. So again, from the first term, it is 1 by q del del beta sum over j pj e to the power minus beta ej. The second term is 1 by q square del q del beta sum over j pj e to the power minus beta ej. So there are two terms appears. Obviously, there should be two terms because we have to prove this part. So from the first part, it is 1 by q is there, so it is 1 by q del del beta sum over j. So you can take out the summation pj e to the power minus beta ej. So again, it will be break in two parts. So it will be sum over j. First part is pj beta e to the power minus beta ej plus pj is constant minus beta and then e to the power minus ej e to the power beta ej. So it is 1 by q sum over of j del pj del beta e to the power minus beta ej, and this is minus ej pj e to the power minus beta ej. Okay, so you can see. Okay, so now this first part is okay. First part we have to consider, because here you can see the del pj del beta is there, and but the second part is important because this is essentially signifies the p average, if ep average. Okay, so let me keep it there because it is important. Otherwise, what will happen if you consider this part as the average, then you can't cancel because there is another part. This part will be cancelled out. This part will be cancelled out. So it will be bit of lengthy, but you can try it. It will be this total part. If you calculate both part, some part will be cancelled out and it will be E average, P average. If you want, I can do. It is not difficult. You have to just rearrange the things. It will be E average, P average. It should be E average, P average. Okay. And E average, P average, we already know there is already E average, P average, and beta EP is there. So you can easily substitute that part. Okay, so if you substitute that part easily, then we can write it. The rest of the part we already derived. So when you substitute that part, let me do it. It should be, because otherwise it does not make any sense if you ignore it. Okay, so let me do it. Let's see what will happen. So it's so okay, minus term is there. So what will it give? Let okay, it is then sum over j 1 by q del pj del beta. You can also check if there is any mistake. You can say it will be called beta ej minus sum over j ej pj e to the power minus beta ej by q 1 by q del pj del beta e to the power minus beta ej, and this part is essentially ep average. Okay, and now the second part. This second part 1 by q square. Now first part already right, so second part is 1 by q square del q del beta sum over j pj e to the power minus beta ej. So it means 1 by q square. This is del q del beta. Del q del beta already we have derived. Del q del beta is del beta. So essentially it will be sum over j minus ej e to the power minus beta ej, and it is sum over j pj e to the power minus beta ej. Okay, so you can see it. So this part, let me divide it with q here. One q is here, another q is here. So again it will be just e average, and it is obviously my e average, and this is p average. Minus term will be there, so minus e average p average. So total term, and this part remains constant. The pj, if you see, pj is not a function of beta. If you see, so this part will be goes away. So only these two part remains, ep and this. So essentially, if you combine it, so two parts we already obtained. So it is our ep minus ep, I guess. No, minus ep, and here it is minus e average p average, but there is also one minus sign, so it is plus e average p average. So readily you can write it. So beta nv equals to minus 1 by kbt square, not beta is there. So it is ep average minus e average p average. So it is there. And what was our main equation? This is our main equation, beta into something. So let me copy it. So this is our main equation. So this is our main equation. And now just look at it. If you take beta common from here, so it will be this, and this is essentially this part. So we can directly write it del beta nv, and instead of beta, if you write in terms of t, then it will be t, and it will be minus kb t square. This will be there. If you see it here, we have already minus kb t square is there, but it's not needed. You can remain it in terms of k beta as well. So in terms of beta as well, you can write it. Okay. So it is okay. So now just write it, rearrange it. So it is del E del V in beta equals to or minus beta del P del beta NV minus P. Essentially, this is our thermodynamics equation of state in terms of statistical mechanics, because you know this is our classical equation. V equals to T into del P del T V minus P. So check it into bracket total. So we can derive it. Okay, so this derivation, it seems that it may be quite lengthy, but you can check it. I will upload the PDF. You can check it. It is not that much difficult. It may be lengthy, but it is not difficult. Okay. Okay. So now let me discuss that question from the assignment. There are lots of questions I thought, but let's take lots of time. Okay.
Okay. The question is from the assignment 5. Okay. From the expression of pressure, we have already discussed so many times. From the expression of pressure, in terms of canonical ensemble, in terms of canonical ensemble or canonical partition function, uh, for 1 mole of ideal gas at 300 Kelvin, in terms of, we have to evaluate in terms of gas constant R. Yes. Anybody has tried this question? Because it was in the assignment number 5 and the submission date is already over. Okay, let me try it. Okay, so what was the expression for pressure? First, we need the expression. Okay, probably it's not visible. Okay, so first we need the expression of pressure. Let me connect it. It's not visible. Today something is happening. It's reconnecting both the Bluetooth and this. Okay. Expression of pressure in terms of canonical partition function, what we have discussed in the last class. What was the expression? That is P average is KBT del lnq del V nt, or more specifically, it is NVT and it is NT will be constant. So this was our expression for pressure. Now what they have asked for the 1 mole of ideal gas. You have to calculate this pressure, 1 mole of ideal gas. So first 1 mole of ideal gas, for 1 mole of ideal gas, you have to consider the, calculate the partition function, capital Q. Then only we can do anything, right? Otherwise, it's not possible to do. So what will be Q? Q is sum over j e to the power minus beta ej. And they have asked in terms of R, gas constant R at 300 Kelvin. That means temperature is also given to you. Okay. Okay. So now, for that, you have to use that formula. Q equals to Q to the power n by n factorial. This is known, right? We are considering for monoatomic gas, only the translational partition function is there. Otherwise, it can't be done. It is not mentioned over here that you have to consider that monoatomic ideal gas, but here we have to assume that. So now if you put it, then obviously ln q will be n ln small q minus ln n factorial, and it is n ln q minus n ln n plus n, which is Stirling approximation, using Stirling approximation. So our pressure will be kBT del del V of n ln q minus n ln n plus n, when that n and v are the constant. So essentially n v constant, n and v constant. So this part will be 0. So only we have n kBT del del V of ln q when only the n is constant, because t already is there. In capital small q there is no n, so only q will be there. N is already taken out from the derivative. So nkbt, nkb, what is nkb? It is small nr t, and this is 1 by q del v, what I'm writing, del q del v at constant temperature. Okay, so this we have to calculate it. Calculate now. What was q of? Q was v by lambda cube. So if you do it, so now del q del v will be, lambda is a function of temperature. So this will be essentially 1 by lambda cube. So put it n at t, 1 by q is lambda cube by v, and this is 1 by lambda cube. So lambda cube will cancel out. So it is 1 by RT by v. It should be, because we know PV equals to nRT. So it is 1 by nRT by v. So P average is nRT by v. Now we have to 1 mole of ideal gas is no. 300 Kelvin is given. R in terms of N is 1, so it is RT by v, and okay, V is there, and 300 Kelvin is given. It's correct, but V is not given, right? So V is important. Otherwise, expression of pressure, V will be there. So anybody has done this?
Yes, but the answer is seems to be incorrect.
Answer is not incorrect, as the question is incomplete, because
Question is involved.
until you don't know the value of V, you can't do it. Okay, so
I
obviously
write 300 R by V.
you write 300 R by V, but actually here the answer is given as 300 R. That means they have considered the volume as 1. That means 1 meter cube volume they want to consider. So question is incorrect. But the correct answer will be your answer is correct. 300 R by V should be the answer. But they have asked in terms of R, so the answer should be 300 by V. Okay, this should be the answer. So you are asking the question, right? Short no deep. Now, is there any doubt in this question?
No, 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 not at all.
The question
Thanks.
is incorrect, not incorrect, incomplete. V is not given. Until you don't know the V, how you can calculate the exact numerical value, right? So question is not totally correct. But the procedure is this. Procedure is or you can done it from you can do it from your basic knowledge with difficult in anatomy. Then you can directly can have the answer without doing this. But they have asked from the canonical ensemble. That's why you need to do it. Okay. So now rest of the question we can do now. Question number 4. Okay. Going back to the screen again. I have to connect it. Okay. Question number 4. Calculate CP or CV first. CV and CP using canonical ensemble or under canonical ensemble, not using. And establish Cp minus Cv equals to NR for ideal gas. Okay, we know this Cp minus Cv equals to NR, but this is for ideal gas. But here we have to first calculate Cp and Cv. How we can calculate Cv? Cv is del U del T
Del U del P at constant T.
constant volume. From statistical mechanics, it will be just this. Okay. And what is E average? We have calculated E average. It is kBt square dlnq del T at constant volume. So just make it derivative. So it will be kBt square del T of, you can see always I write del T. Why? Because because this is partial derivative. This is not the ordinary derivative. kBt square dlnq del T. So again, we have to divide in two parts. First, let's say kBt square is constant, then it will be d2 dlnq dt square constant volume plus 2 kBt dlnq del T constant volume. So this is our CV, sorry. This is our CV. Now CP, how we can calculate? What is the formula of CP?
Del H del T at constant P.
Exactly. Del H del T at constant P. So in statistical thermodynamics, we have to consider this. And in last class, we have already evaluated the form of enthalpy. What was the form of enthalpy? This was
U plus T.
KB. Do you remember the form? KBTL DLNQ del P NV. Here also NV should be there. NV should not only NV, because this is differentiating with respect to T, and you know the energy is function of NV and T, so NV must be there. It should always be correct in terms of variable. It does not matter.
N is mandatory.
No, N is a number of particles.
But
Mandatory
I'm
is
saying
if you think in terms of the mathematical parts, then it should be there, because you see, because you are differentiating with respect to temperature, so other two variables should be constant. Now this is partial derivative. Starting
yes,
at this
but n
point,
is always constant.
no, why n should be always constant?
Number of particle.
No, no. Here, when you are taking the derivative with respect to temperature, then the n is constant. Okay. But let's say
Okay.
you see now when we are calculating pressure, what was that? You are taking the derivative with respect to volume, that E, J, V, right? Like these things. So that you can take the derivative with respect to n as well. You will see when the grand canonical partition function will come. But here always n is kept constant because we are taking the derivative in terms of t. Here you can take the derivative in terms of v as well, or in terms of n as well. Does not matter. This can be there. Okay, you can do it.
It is also internal energy.
No, no, no. It is not internal energy. Here
CV.
this no. This does not signify any physical quantity. That's why we don't use. If it signifies any physical quantity, then we have to use it. Okay. Here this does not signify any physical quantity. But when grand canonical partition function came, that then you can see this will signify something. Okay. But to be mathematically correct, we have to consider n and v there. It should not deduct the marks, but or the calculation will not be hampered, but still. You see here I am derivating with respect to volume, so we have to consider n and t constant here. When we will derive, let's say, an arbitrary situation n, then obviously v and t should be constant. Why we are not considering this part? Because here this will not give any physical resemblance to the classical thermodynamics. If this term will also be something in the classical thermodynamics, then we have to consider it. Okay, you will see that mu will be come from that. Later we'll see, but this is the h. So Cp will be just, we have to take the derivative. Let me write it, kbt square, and it is kbtv. Okay. So from first term, it will be kbt square d2 dln q dt2 nnv plus 2 kbt dln q dt nnv. From second term, it is kbv dln q del v np plus kbtv. Oh, only one thing will be there. Okay. Because temperature is constant here, so q is function of nvt. When you are differentiating with respect to v, then that temperature will be comes out. So for being mathematically correct, let me continue. Okay, later you will understand that, but still it will be d2 dln q del t del v. See, here I am writing n only because it is derivative with respect to temperature and volume both. So obviously only n will be constant now. So that part you have to keep in mind always. What are the partial derivatives? Okay, so now Cp and Cv is there. Now what will be Cp minus Cv? This is Cp and this is Cv. So this term is there, I think. Yes. This term is common and this term is also common. So only these two terms will be there. Kbv dln q del v nt plus kbtv d2 ln q del t del v constant of n. Okay. So now what was the question? We have to establish this as minus as NR for ideal gas. Okay, and ideal gas means we have to now consider that monoatomic ideal gas. You can do it for other as well, but here we have to consider only for monoatomic ideal gas. And you can see that should be only monoatomic. That you can argue that why we are considering only the monoatomic ideal gas. There must be other things as well. Here also in previous question, we are considering only monoatomic ideal gas, right? But if it is not monoatomic ideal gas, then what will be the changes? Is there will be any changes if it is not the monoatomic ideal gas?
In the Q,
In the Q, we have to consider the other Cartesian function, right? The
yes,
rotational, vibrational. But you see, in first one class, I said that Q, total Q, is actually function of Q translational, which is function of temperature, volume. Other all rotational, vibrational, electronic, all are function of temperature only, not the volume, right?
yes,
And you see here we have to take the derivative with respect to volume. So this part will be zero anyway. This contribution will not be there. Okay.
okay,
You can think that, but that contribution will not be accounted. This part will always comes due to the contribution of translational motion. And you know this ideal gas equation, V equal to nRT, that is for ideal gas. That means there is no interaction. That is due to only translational motion. While deriving this P equal to nRT from the kinetic theory of gas, you can derive P equal to nRT. There also you don't consider the vibrational or other things, electronic or rotational, just translational motion. So this P equal to nRT is totally artifact of the translational Cartesian function, translational motion. Okay. What was so this is the form. So now we have to consider these two derivatives, dl and q del v. So we can write it v 1 by q.
I've got one query to make.
Mm-hmm.
In the second term, there is a derivative with respect to temperature also.
Hmm.
So shall we not take the temperature effect of other partition function?
No, first there is a derivative with respect to volume. So if that is zero, then the what will effect of the derivative of temperature? Let's say
Okay. Okay.
you have a function of x squared y, something like this, and you are taking derivative both in terms of, let's say, um, x in terms of y. And if there is no y or there is no x, then obviously this first term is always zero. Then what is the meaning of the second term? You can say this is y or this may be y square. So you can think. So we have to consider, but there is no x now. So that part will be zero. And you multiply it with zero, so it will be zero. That
Okay,
contribution will
understood.
be
Thank
zero.
you.
Okay. So this part, let me keep aside. This part we'll discuss later. This is not very easy. First, see this. What does it give? Del Q, del V. Q, and del Q, del V, N and T. So Q is Q to the power N by N factorial divided by V. Or it is better to consider the ln Q. Okay, it's better to consider the ln Q because then we can use the Stirling approximation as well. So let me do it. dln Q del V. And it is NT. And ln Q, Q is Q to the power N by N factorial. So ln Q, N ln Q minus N ln N plus N. So see, just the first term will be there. So it will be N d ln Q del V only temperature. See, when we take the N out, only temperature will be there. This thing should be correct always. So N, so it is 1 by Q del Q del V at constant T, and Q only the translational, and that is this part we have already done. So this is our V by Q. So it is n lambda cube by v, and this is 1 by lambda cube. So it is essentially n by v. So this part gives us n by v. So Cp minus Cv will be Kb v, Kb v. This part gives n by v. So it is n Kb. So it is nr. And now see, so this part already gives nr. So why this part is important? That is question. Now for ideal gas, this part is 0. But if you don't consider the ideal gas, this part will survive. You know, uh, this equation is only, if you consider the original expression for Cp minus Cv, I forgot the original expression Cp minus Cv. What was that? But in original expression, there was two terms. This part only survive when the this is not ideal gas. Otherwise, it will 0.
Why?
You can do it. Let me do it. This derivative. What does it mean? Del del T of del del V of.
ln q
So this derivative we have already done. What is this?
n by v.
Is there any T?
No.
It is 0. If it is
Okay.
not ideal gas, then but for you can check with van der Waals gas. It will not easier. It will not easier because in that case you have to identify the Q as well. Q is known. Q is known, but then you have to consider that part because for ideal gas this is correct. Otherwise, it's not easier. Okay. So now it is okay. Next question.
So one query: how to
Yes.
find the Q for van der Waals gas?
The small q,
No, capital Q.
capital Q, you only find out in terms of the small q, that is the molecular partition function. Otherwise, there is no way to find out the capital Q. Capital Q, let's say it is q to the power n, or there may be the n factorial. So Q is known. Q is that Q translational, Q rotational, Q vibrational. These things are there. So, but
Mhm.
these, while deriving Q translational, you may think that that was considered a particle in one-dimensional box. By using that, you have derived now. So that all derivation are essentially for the ideal gas or ideal molecule. So that formula is general, but you can't use for van der Waals gas or these things. For that, you have to use the canonical. You point out the same thing, good thing, that this equation I also argued that, let's say for this part, this is kb p square dlnq del t. This is a general form. Okay, you can use for van der Waals gas, interacting gas, solid, liquid, for anything it's correct. But when you
Mhm.
write it as kb p square dlnq del T, in terms of N is coming out here, in terms of the molecular partition function, that means you are assuming the ideal gas. The molecules are not interacting. Then only you can write it.
Mhm.
Okay. When it is van der Waals gas, you can't do this step. This step is not valid. Okay.
Okay.
because they are interacting. In that
Oh,
case, you have to use this equation. There is no explicit form. You can say this is the explicit form, but you can't write in terms of molecular partition function. In canonical ensemble partition function, you can write it. But when you connect with the molecular partition function, then you have to consider in this interaction how you can account the interaction. There is interaction between the molecules. That is because you can't write q equals to q to the power n or q to the power n factorial. You can't write it when there is interaction. Okay. So in one way, answer you don't know for van der Waals gas. You know in terms of capital Q, but you don't know in terms of small q. It can be anything. I was saying for checking the derivative only, but okay, that is not also a correct statement. Okay. So it is question number 5. Okay, so from okay, the translational contribution to partition pumps to entropy is proportional with mass of the particle raised to the power alpha. Find out the alpha. Okay, so we have to find out alpha. That is translational only. It's saying that it is proportional with mass, any mass of the particle, and that is proportional to alpha. So we have to find out that alpha value. The question is clear. It from second order equation we can do it. Let me check the question again. The question language was like this. Let me confirm it. 1 minute. Let me find out the question. Where was the question statistical?
It's question number 12.
Question number 12 from where?
Assignment 5.
No, I'm not. This question is not from assignment. Okay, this I. What was the question number 12 in us?
Sorry. It's not.
No, this is thermal wavelength.
Thermal level. Okay.
This question I will also do, but this question is okay. Okay. Okay, I got okay, now question was like, question is not totally correct. We can, when we will solve this, we can see it. Let me write the proper question. I checked it. Okay, this is said that the question is proportional with alpha times ln m. Okay, this is mentioned where m is the mass of particle. Find out the alpha. Value of alpha you have to find out. So means that it is proportional. Instead of alpha, let me write it gamma, because this proportional and alpha signs look similar. So it is gamma ln m. So we have to find out the value of alpha, gamma, what it would be. So what we can do here? What should be the approach? This is not very straightforward question, right?
What is the expression for entropy?
You know this translational contribution they have asked. You know the entropy expression. What was the expression for entropy? Kb ln q plus del E
E
by
by T.
t. Now write it. E is kb t square dlnq del T NV. So it is kBT dlnq del T NV. So now they want to ask translational only. Translational means Q is only Q, we know Q is Q to the power n by n factorial. Okay, so if you put it Q equals this, then we will have S equals to KB. ln Q will be this, already we have done. This is ln Q, n ln Q minus n ln n plus n. So it is KB ln Q minus KB n ln n plus n KB. And the second term, on the second term, it will be kBT d ln Q del T V n. Okay, is it clear?
Yes.
Okay. So what will be this integration? So sorry, derivation. So after differentiating, we will have kb ln Q minus n kb means nr ln n, and this is again nr, and this is kb t n kb again nr t. It will be 1 by q del q del t v. So now why they have said only translational? Because if it is only translational, then this q will be only translational, because this is not derivative with respect to volume. So it is not all will be the same form. We can't say it here. Only the translational part. Then all q will be q translational. Okay, and this is this part. This will be a not p. Q translational, you know, that is lambda by v by lambda cube. So lambda cube by v into 1 by lambda cube. Already we have done. So it is nRT by v. Okay. T was there. T was there because it is kb t square. 1 t should be there. If there is any mistake, you can say it. Okay. Maybe there's a mistake will be there. Okay. So it is nRT by v. So it is p essentially. nRT by v means. But here is only energies must be cancelled out. One term should be cancelled out. Is there any mistake? Okay, let me check. N is there. So Q, ln Q instead of ln Q, n acha. So we can write it. Here also one n will be there. Minus n ln n. So it is kb n ln n plus n kb. N kb is small n, correct? And this will be plus. This is plus. I think it's correct. You can write it also nkb. nkb ln q translational. What is q translational? You know. What was q translational?
By m kbt by h square
kbt to the power
whole 3 by 2.
Or even use this formula as well, v by lambda cube. So if you use this v by lambda cube, you will have direct v by lambda cube, and this was all n kb. N, no problem. nr nr ln n plus nr, and this is something inactive by V is there.
All terms do not have QT.
All terms
Do not have QT.
QT
Yes, translational. So
translational.
how can we add the M?
I don't understand. Repeat it, repeat it.
To compare the power of M, we need to common M first. Need not it?
Some noise is there. I can't listen you. You can write in the chat box. I also check this because ultimate expression I know. That expression I know.
Okay.
But it should be done. N is there already. Okay. Let me check it. Okay. KBTLNQ is there. If you put it LNQ because this part has not done here. Just the rest of the calculation is done in the book. N ln n plus n is ln in factorial starting approximation is correct. Multiply it with all KB and n is constant. So rest of the part is zero. It's correct. Okay, there is no problem. So 1 by Q del T V. Okay. Okay. This is not correct, na? Because this 1 by lambda cube is not correct. This is for when del Q T del V is there. Here temperature is variable. Okay, that's why I'm thinking. So this we have to calculate. Del QT, del TV. This is not. Okay. So it is del T of what was QT? QT is h square by root over 2 m pi kbt to the power 3 by 2. This we have to take. So this means rest of the part is constant. So it will be h cube divided by 2m pi kb to the power 3, 3 by 4, right? It is no. It is half root over half, and there is only 3 is cube.
There is Q.
It's correct now. 8. This is correct now.
Yes.
Yes. H cube, and this will be 3 by 2, and it is del T of 1 by p to the power 3 by 2. So it is h cube divided by 2 m pi kb 3 by 2, and it is minus what? 5 by 2, 3 by 2 into t to the power 5 by 2. Okay. So it will be minus 3 by 3 is 4, not 4, 3 by 2 is there. Let me write it. 2 m pi kb 3 by 2 and t to the power 5 by 2. Okay. So this is, and also there is a 1 by qt. So when you divide 1 by qt into this part, that is del qt by del tv. So we'll have 1 by qt, and 1 by qt is this. So 1 by qt will be 2m
Root
pi
2
kbt to the power 3 by 2
by square.
and minus term will be there. It is 3 by 2 h cube 2 m pi kb 3 by 2 e to the power 5 by 2. So what will it will be goes so it is minus 3 by 2. Check, okay, if there any mistake you check it, it will be t. So minus 3 by 2t. Okay, I think it's correct. Minus 3 by 2t is there. So now if you put it here, it is minus 3 by 2t. So it is essentially, so S translational will be, the terms are, first is this nr ln qt, then it is minus nr ln n plus then nr, and this plus nrt, and when you minus will be there, tt will cancel, so it will be 3 by 2 nr. Okay, so it is minus 3 by 2 nr. Am I correct? Check it. 3 by 2t, so 3 by 2t, tt will cancel, minus 3 by 2 nr. Yes. So 1 minus 3 by 2, what will be? Minus 3 by 2, half nr. Oh, plus will be there. Something happening. Minus sign should not be there. Okay. Oh, where is the mistake? Check. Here should be the plus. When you do it, del n t, minus is coming. That should not be minus. Is there any mistake? It should be plus. Okay. Plus 3 by 2 nr. I don't know why this is coming. By q. T to the power 3 by 2. So it should, that minus should be there. And for the here, maybe the minus, it is minus here. Okay. The minus cavity square should be there, right? Oh, that's why I think del t and e was. Okay, I will check it. Okay. Because it should be plus, because in the final expression, there is plus. There may be some plus minus mistake is there. So it is nr ln n, nr ln n plus 5 by 2 nr. So you can write it, it is as 5 by 2 nr ln e to the power 5 by 2. So essentially the S translational will be nr ln qt e to the power 5 by 2 divided by n. And qt, you know, qt is v by lambda q. This is the formula, nkb ln v to the power 5 by 2 lambda q. So this plus minus mistake may be there. I will check it out. Okay. So this is our translation contribution. But the question is, what is the proportional constant that gamma that we have to find out? So now using this equation now, so st you can write it. Nkb is constant. It is will be ln v plus 5 by 2 minus 3 ln gamma. Check it, minus minus 3 ln, because lambda cube is there, lambda is this, and so lambda I will be, so now write it just this ln n. So it is correct. So just put the value of lambda. So ln v plus 5 by 2 minus ln n minus 3 ln h by root over 2m pi kb t, because it is whole to the power cube and cube will be there, 3 will come out. So this is our form. Okay. So again we can write it in kb ln v, this is capital V volume, 5 by 2 ln n minus 3 ln h, or we can write it ln h cube, then plus 3 by 2 ln m plus 3 by 2 ln rest of the part 2 pi kbt. Okay. Okay. So this then we can write it n kb ln m to the power 3 by 2, because this means that ln m to the power 3 by 2, and you can write into, because these are all in terms of ln, all included in terms of ln, so you can do it. Just take it, you can write it as v e to the power 5 by 2 divided m to the power 3 by 2, then h cube n, and this part it is also in plus, so it is 2 pi kb t to the power 3 by 2, so it will be there. Just I have opened that lambda in this equation. You can open the lambda, you can get this, you can get this. So now you can think ln ab, ln ab is ln a plus ln b, so it is n kb ln m to the power 3 by 2 plus n kb ln rest of the part v into to the power 5 2 pi kb t to the power 3 by 2 divided by n h cube. Okay, so you can write it 3 by 2 n kb n ln m, and this part I can consider as a constant c. So now you see c translational is proportional to, because this is plus additive, so it is 3 by 2 nkb. Nkb is also constant, so 3 by 2 nlm. So S translation is proportional to 3 by 2 nlm. Or you can write it from here also, proportional to m to the power 3 by 2. Both are correct. And that equation, you know, this equation is called Sekut-Trotter equation. This equation is called Sekut-Tetrode equation. And this is the direct outcome of Sekut. This is very useful in problem. It is very useful. If you remember this direct result, then you in the problems. So essentially this part is gamma. So gamma is 3 by 2. That was asked. That constant. Okay. And this plus minus while something is taken there, I will check it out. Okay, I will check it out. This will be plus only. But this form is known. This is Sekut-Trotter equation. There is e to the power 5 by 2. Okay. So let me stop. If you have any doubt, you can ask from any part.
If the question is that s varies to m to the power x, then what should be x?
What? Oh, okay. ln e to the power x.
No, only m to the power x. Then what should I do?
Like this, m to the power x.
Yes, what is the value of x?
Because but there is ln. So
Yes.
then you have to break the ln part, and you know, if you when you break the ln part, there is approximation, so that will not be asked, because ln is there. It is not straightforward. We have to consider that series, ln series. Then if it is also, if it is m plus 1 ln m plus 1, then also it can be asked, but it is directly ln, so no, it is not directly to x for something. It's not.
Okay.
Okay, so let me stop sharing now. in if you have any doubt, you can ask me. Okay. Okay, so if there is no doubt, you can now you can leave and we'll again meet in the next class. And if in next class we'll discuss that rotational and vibrational particle and function related question. Okay.
Okay, thank you.
Okay. So thank you for joining in this meeting next class. Okay. So now I'm